Hello, my name is Benjamin Gansa, and I'm making this presentation for my final project for GSCS 6321. That's the special data structures. And then the topic that I chose to do was to assess building vulnerability using the KD3 nearest neighbor assessment search, nearest neighbor search, and I'm applying this in uh, the Little River area, adaptation area in Miami-Dade County. So, in today's increasing urbanized and data-prone world, spatial data structures play a critical role in supporting emergency response planning. So, my study focus on determining the proximity of residential buildings to evacuation facilities using the nearest neighbor approach. And then the nearest neighbor approach, which incorporates algorithms such as the KD3 and then the brute force, is sufficient to solve fundamental spatial problems, such as finding the process facility in each building based on geographic coordinates. And then the motivation for this work lies the ability for the spatial data structures um, such as the KD3 to support disaster preparedness through rapid spatial query in situations such as hurricanes or flood, in which the steady area, Miami and perhaps even Florida and then some part of Texas are prone to. It's essential to know which communities are farthest from evacuation points and hence most vulnerable. And this can actually save lives. So the objective was to analyze and evaluate spatial data structures for nearest neighbor analysis. And then the first objective was to compare the brute force and then the KD3 algorithms. Then the second one was to compute distance-based vulnerability and then also to visualize the map as well as calculate the time complexity. So this is the study area. That's the Little River adaptation area in Miami-Dade County. And that's very close to, I mean, the area lies in the intersection of the Miami River and very close to the Ocean Bay, the beach, the Biscayne beachfront. So it is highly prone to storm surge flooding. So the data source, I use the building footprint of 499 buildings and then 4 evacuation facilities. And the data was in different projections, so I had to project it into the UTM Zone 17 coordinate system where Florida falls. So this is a bit overview of the algorithms. That's the two main nearest neighbor search algorithms that I use. So the brute force and then the KD3. And as can be seen, the brute force is exhaustive pairwise comparison. However, the time complexity is higher, okay, compared to the KD3, which uses binary space partitioning, which has the time complexity of big O of log n, okay, and then it does a tree transversal plus pruning, and this make it more time efficient for mid for small to mid data processing, as in this case of my study. So this is how I implemented the algorithm in the Python environment. Okay, so on the left is the diagram that shows the algorithm implementation itself, and then on the right is the time complexity code that I use, and then I implemented this in the Jupyter Notebook. So the result A and B shows how, so each algorithm determined the process facility. And you can be seen that both did almost the same. Where on the left, using the brute force, it kind of partition the buildings based on distances. So distances close to facility A is up there, and then distances close to facility B is also down there. And a similar one can be seen for the KD tree. Okay, so it also shows that, so out of the four facilities, um, facilities 1 and facility 3 were among the closest. Okay, so based on the nearest distance, that's from each building, it's either decide facility 1 or facility 2 or facility 3. And from the diagram, we can be seeing that both algorithms almost did the same thing. Anyway, this is the total number of points is buildings is 499, so wasn't so much. Though it wasn't so much, however, there was still some time difference, okay, when it comes to the time efficiency analysis. And as I mentioned earlier on, theoretically, KD3 is way faster than the brute force. And it can be seen that in this instance, for 100 queries, the KD3 use very, very small of 0.00747 seconds. Okay. Compared to the brute force that used 0.002985 seconds. And that is approximately about 4 times. So the KD3 is approximately about 4 times faster compared to the brute force. Okay. And then I also inserted some uh, some charts. So in the final vulnerability map, I divided the distances to the buildings into 3. Okay, so based on the highest and then the lowest distance, I divided it into 3. Okay, if a building is within the first group, meaning that it is very close to the facility, and then meaning it's less vulnerable. If it is in between them, then it is medium, has a medium vulnerability. But then if it is further away, okay, that's closer to the highest, longest distances, then meaning it is the most vulnerable. Okay, so based on that, I was able to develop building vulnerability maps, and you can be see that in the map here, the red areas has the highest vulnerability. Okay, it just to say that whichever facilities that they are mapped to, it takes longer to get to the facility compared to the medium and then the low vulnerability one. So that can be seen in the score here. So in effect, the study that I implemented provided a very high accuracy, and then though data set is not so big, however, the algorithm was able to implement on our data set, and I was able to identify the clusters of building vulnerability for flooding. And then this actually shows that spatial indexing in GIS application can really be applied in the real world example, and can support evidence-based evacuation planning. And in the real world, that can also help to minimize or determine the resilience of a city. So these are references that I use. I will post the YouTube link here. And then thank you for listening.